Okay, so in the PowerPoint slides, I put up crest, trough, and different types of waves, okay? A transverse and also a longitudinal wave. All right, so first off, a transverse wave is our typical looking wave, okay, like this. Now an example of that would be waves in a string like this, or ocean waves, anything where you have this motion. Now if you notice here, if we put a point on here, and in class we'd do this with a string, but if I were to go like this and shake this, this point only goes up and down. So the wave goes this way, but any point along the wave moves perpendicular to the wave motion, okay? So this is a transverse wave. We also have a longitudinal wave, or a compression wave. If you were in class, we'd show this with a slinky. So one person will hold one side of a slinky, the other person will hold the other, and they would just move it back and forth. And you would get these compressions and stretches, compressions and stretches. I'm gonna start out with this one because most of the time in class, I'll just draw it no matter what. I'll draw everything looking like a transverse wave because that's what we're used to. So example, this one, water waves in light, or waves on a string. This would be, the easiest one is sound, is a longitudinal or compression wave. So this right here would be a compression. That's an R. And this right here is a stretch, or a rarefaction. That's all one word. I always make a joke about, like, it's not like 92 over 113. It's not a rare fraction, it's a rarefaction. It's a pretty pathetic joke. Anyway, so that's that. Now let's do all the parts on this up here. So first off, the point of highest amplitude is either a crest. We'll label this as the midpoint. And the distance from the midpoint to the uppermost point is the crest. This right here would be the amplitude, A. Now the low point is a trough. Now this is bad too, because I want to do this joke. I always pull up a chair and I talk about cows and horses eat out of a trough. So it's the distance from the midpoint to the lowest point of the wave. A lot of times they'll say that crest to crest or trough to trough is a wavelength. And that's my lambda. But it doesn't have to just be that. If you look back at your notes there, hopefully that you took, it's the distance between two successive identical points on a wave. So if I have a point here, where does that point happen again? Some people think here, but no. Here. This would also be a wavelength. I think when you're younger, they always just say crest to crest or trough to trough to make it easier. Okay? Now, two other words that came up were frequency and period, okay? Frequency is equal to 1 over the period, or the period is equal to 1 over the frequency. So frequency is measured in hertz, which is Hz, and period is just measured in a time. Maybe seconds. For us, it's normally seconds. So I'm going to erase some of this stuff if I can. Oh, that didn't work. Let's just do the whole thing. that the midpoint so let's say this takes place in a time of 1 second, this right here, right? What is the frequency? So the frequency is how many cycles per second. All right, that's what 1 hertz is. How many cycles per second? So if we look here, we have 1, 2, and a half. Okay? So the frequency for this one would be 2.5 hertz, or 2.5 cycles per second. If I want to know the period, or how long does it take for 1 cycle, okay? So you think about it, how long does it take for 1 cycle? It's the inverse. So the period would be equal to 1 over 2.5. That's bad. 1 second divided by 2.5 cycles. 1 second divided by 2.5 cycles. And that would just be measured in seconds. So it's just the inverse of each other. Now, if I wanted to figure out the speed of a wave, like this, the velocity is equal to the frequency times the wavelength. And if I were to substitute in there the period, okay, for frequency, I would get velocity is equal to this. I messed that up. See, because for frequency I put in 1 over the period, and so that means the period would be on the bottom. And this is how to figure out the velocity of any wave, the speed of any wave, whether it's a water wave, an electromagnetic wave, anything like that, okay? So this is plenty of information now to actually fill out worksheet number 1 and do that.